Hello, everybody, and welcome to Rocket Lasso Live, Season 7, Episode 9, I believe. How is everyone doing? We have once again delayed Winbush being a guest on the stream. This time it's kind of my fault, where I did not realize that the liquid stuff was coming out. In fact, to the extent I knew, I thought it was tomorrow. So it's a bit of a surprise, but I figured everybody would want to talk about some of the new features inside of C4D. So Jonathan Winbush will be joining us for sure next week. Cross my fingers. How is everyone doing? We've got people on Twitch. We've got people on YouTube. I think for the most part, we will be kind of focused on some of the new features. Specifically, I think we're just going to explore Liquid. I intentionally haven't played with it yet. I watched a little bit of the Max On live stream today. And then I had seen a bit of the presentation when they did a preview of it a couple of months ago. So you're going to get to see me try and meticulously tackle it so we can kind of learn the parameters of it and understand all the ramifications of it and tinkering around with that in general. I'll pull the mic a little bit closer, but I don't really have a setting to make it any louder than it currently is. My microphone is currently maxed out as far as this application is concerned. So that is the plan. So we're going to focus on questions that are mostly around the new features, and let's see how that goes. I'm going to go into, hopefully this works. I forgot to, okay, it did work. It just started thunderstorming over here like super crazy. There's just like a 2-minute long rolling thunder sound. So there's actually, yeah, do you hear that? Wow, that's a huge one. Anyway, if you hear thunder, we got a crazy storm going on over here. So here we are inside of the new version. In theory, the only thing I've done is I linked all of my plugins in, which should all still be working, and I've added in my asset browser, and I still have my particles preference. Besides that, this is all super vanilla. Some new features to talk about. I know there's a couple tweaks in Redshift. There is that. Oh, I'm totally blanking on what the name of it is. What is UDIMs, right? UDMs, or there's like a new type of like material breakdown system. I'm not familiar with that. It's not a workflow I use. I think that's a lot more so a video game breakdown or a video game feature. So I'm not too worried about that. Some other things that were mentioned. I'm mostly winging this, everybody. Another new thing is that there are a bunch of, let's see, new capsules. So here's new capsules that have come out recently. And as far as I know, are they in here? I thought featured content. Aren't there a bunch of new LabWorks trees? I thought they'd be showing up here in the new capsules. Maybe they're hidden somewhere else. Ooh, the joint spline. The joint spline seems to have shipped. So there's a new capsule that Rocket Lasso made. I did not realize that was now live. So that's super cool. Yeah, we might be able to spend a couple minutes talking about the joint spline. That could be cool. I was trying to find, if I search for LabWorks, I'm not sure how to spell it, but if I say lab, nope, what is that? No, don't do that. Maybe my asset browser is not fully updated to that content. Bernd is here. Welcome. But anyway, there's a bunch of really cool new trees that they have, I think, from LabWorks that essentially you can do a bunch of different iterations of them, like the fall variant and the young variant and the winter variant, which is really, really cool. Another important detail is inside of the asset browser, they've now got this AI search. So this is purely AI search. I consider this just a pure positive, but if I literally this first time I'm doing this, but if we click the AI button there, yeah, it's entirely in our local thing. No data is transmitted. That's very nice for the Max to tell you. Probably only pops up the first time you click that. So now we've got AI search going. So now if I search for the word bedroom, now you can see that, yes, it's finding words like bed, but it's also finding a lamp that is appropriate to it. Now, I'm not entirely sure what they're keying off of, if it's keying off of the thumbnail, if it's keying off of the metadata that's typed in. Because if you make any object in the asset browser, if you click on this little drop down, you get extra details. And here we click on keywords, and you see here they put decoration, decorative element, light stand, lighting. Now you see, as far as I can tell, nowhere does this say bedroom, but maybe based on the word decoration, decorative element, light stand, it's like, oh, I think that this is something that might be in the bedroom. So now you can do these way more abstract searches. And then I don't know. I'm going to type in the word orange. So now here's the word orange, and now yeah, in general, it seems like we are getting a bunch of things that are kind of orangey looking, where it's like these are lemons. So the word yellow or the word orange is presumably, yeah, you see the word yellow, but the word orange is not here. But it is found. It's like, oh, an orange, a lemon is pretty dang close to an orange, so I'm going to include that. So essentially, we get a lot more of a dynamic search here, and of course, orange images and orange materials. But yeah, even just from these thumbnails, where like I doubt the word orange isn't there, but it saw the thumbnail and it knew that that was something that's orange. So yeah, I consider this AI search pretty cool. And then I saw Ellie demoed. If you click this AI, you can also do similarity search. So I don't have anything prepared here, but why don't we just try something? Hang on, I'm gonna switch screens for a moment so I can get a clean window that you can see. Boop and boop and boop. Yeah, that should be fine. So let's just do a Google image search for um, what's something generic. Um, I'll just say tree. That's tree. So search the word tree. There's all these images. That's fine. I'll even grab something like that, and let's just download it. Save image as. Hang on, I'm always worried about stuff like beta stuff and whatnot appearing in my my downloads folder. So I'll pop that back up in just a second. Where's my downloads folder? Downloads, tree, open location. I think that's probably fine. Boop. Okay, so now we can go into Cinema. Let's do AI from file. Let's go to downloads, grab this tree image and say, okay. And now just from that image, it's now looking at that image and it's like, okay, what are things that look like that? And now we've pulled up a whole bunch of trees. And now, like, even here, this is cool. I had no idea what the results were going to be for us, but like, look, there's no palm trees here. So all of these are falling way more specifically into something that looked like that. So yeah, very, very cool, very powerful. I dig it. And then you also notice that we have a search image from clipboard. So I could probably just have taken a screenshot and then said, do it from whatever the clipboard's doing. And then from viewport. So let's do another experiment here. Let's do this as absolutely simple as we can. I'll just make a cylinder and make it a little bit wider. I don't know what this will do, but let's zoom up on it. And now go back here. Let's do an AI search from viewport. And interestingly, it found my noodle models. Like, actually, that's a pretty good example because this is coming from the Rocket Lasso asset browser that I have. So these were not specially calculated. So this is definitely coming from my thumbnail that I found these two types of pasta that I modeled some time ago, and it's making something very simple. Now here you are seeing that it seems to be really keying off this gray color. So color, I think, is a major variable here. Now, if we were to let's drop that on, and now you see it looks kind of metallic-y. So let's try searching again. Search from viewport, and now it's shiny. So now I found like a glass of water to go along with it. I was wondering if we get like any cans or anything like that. But we're seeing a lot of metal searches, some green materials that are kind of similar to that reflection. So yeah, a bunch of really cool little AI search tools in there, which is, I think, one of the absolute best cases for AI. Yeah, let's see. Somebody said that I should try searching lab, and I knew they had an unusual spelling for lab, but yeah, they're not showing up in my asset browser, and I'm not sure why. Maybe those haven't quite shipped yet, or maybe my asset browser hasn't synced with it. I don't know. Another thing I didn't see get mentioned, but it's a small thing, but I think it's pretty handy, is all of our spline primitives now have control handles. So if I zoom on out here, you can see that we now have handles making this up. So we can just change the length of our helix, and I can shrink down one side, make the other one larger. If we make a rectangle, then now we get handles, so we can change the scale here without moving inside. So, a tiny little thing, but super handy. Like all the time, I just need to modify that, and now I can do it right there in the viewport. I've only checked a couple of them, but yeah, so here's a start, make it more pointy, make the inner points go out further. So the text object doesn't have it, but I think most of the rest of these do. The wave won't because that's a capsule. The flower, yeah. So pretty cool. Get some handles in there. Like I said, I'm not going to address the UDIMs. I know Redshift had a couple of additional tweaks, things I'm not super qualified for. I think the portal lights are improved, and um, there was something else that I'm. Oh, I think they have a better, an updated version of the denoiser. But I think, um, yeah. So Eric, you just got here, but we're gonna spend most of our time playing with the particle, the new liquid simulation, and I have literally never touched it. I have not loaded it in a single time. So I think we might as well dive into that. So most of the questions here from here on out is going to be me exploring this, and then feel free to ask questions or kind of be like, oh, could we do this with it? Could we do that with it? So let's find out what we're doing here. Now, the first thing we might do is add in these new liquid things into my particles layout. So if we go to simulate, of course, we get these lovely highlights. So here you can see there's a new liquid fill emitter. I'll tear this off. And this is highlighted. So we have a new modifier, which is liquefy. So I'll tear this off. And then we also have right here just a straight up liquid mesh. So those seem to be the objects that are brand new that I would like to add to my interface. So I'll tear all three of those off. Now, here's the tricky part is, look, I've already filled up every possible space here. So I've only got one slot left to fill this in. So I'm trying to think if there's anything here I can remove, because I don't want to remove those. We could remove these separators. I do kind of like the separators, but they're also separated pretty well by color. And we're only adding three things in. So let's see how it goes. I'll right click. We will say, where is it? Customize palettes. Scoot this away. I would like my liquid fill emitter. So that's a new emitter type. So we'll put that up there. I'm going to double click to erase out that separator because I don't think I need that one in particular. And then we don't really have stuff like the meshers and whatnot down here. So we do have the matrix and the tracer. So I think I'd probably put my liquid mesh to hang out down there with them. And then we've got liquefy, and this one's super important. So that's got to hang out here. I'm just going to push that out of the way. So I'm going to pull this up. So what other, I want that separator. I like these separators. Just too many good objects to work from here. Ooh, deflector. Goodbye, deflector. We never use deflector. Okay, and then liquefy. It's gonna be new, but I should put it somewhere appropriate. I think like, yeah, we got flock, predator, prey, and now I'm gonna put liquefy. I feel like those hang out very well together. Okay, so now we go back into our interface, and I think we just close this, and then now that locks our interface. I can close these down. And now I'm going to override my particles layout, and I share this layout between all of my machines because this is linked via Dropbox for me. So I'll just say customize, save layout as, I suppose. So save layout as, and here's my particles layout. So I'll just say save, yes, replace. And now I've overridden my original one. So now whenever I open this up, we get our liquid emitter and other features like mesh and the actual liquefy. Okay, so liquid fill emitter is specific to liquids. We'll save that for a moment because I'm pretty sure we can just apply the liquids to any emitter. So let's start out as basic as we can with a basic emitter. Let's hit play. And remember, this machine is a lot better than my tower, but it always takes a second for it to initialize. And then every once in a while, it loves going turbo speed, but a lot of time it doesn't run like crazy well. So let's just keep that in mind. I'll immediately give us a few extra frames here. And let's make a liquefy. So I'll click on that. And the instant we do, it's doing something. Let's give it a second. Okay, stuff is happening now. Now you see they're all immediately falling. Ooh, that's not super fast. Is that I know a lot of stuff is they're recommending a specific type of video card. Obviously, this laptop just has what this laptop has. Oh, now it wakes up and it's going fine. So like that's the weirdness I was just describing in this machine. Go figure. Now immediately you see I just created this liquefy. Ooh, let me make these larger so you can see them better in the stream. Particle group, and let's say 3. Okay, nice and big. So now we can see all of these falling, and they are reacting in some sort of way. So obviously gravity immediately taking hold. They're using the radius of the basic particle. So each of these in theory has a radius of 1. Um, Liquid contribution. Okay, interesting. It looks like we can make it slightly liquidy or slightly not. We'll find out. Constraints. Okay, yeah, these are going to be the stylistic settings that are probably super duper important. How much, yeah, how much viscosity, how much surface tension. Like this is the sauce right here. This is what we've been not having with all the different simulations we do. How many times have we had questions from everybody? Um, how many times have I had questions where it's like people want to be faking liquid simulations, and now we can do it. Now, I will say, just from the stuff I've seen from other demos, this is very much supposed to be like a MoGraph liquid solution. You're not supposed to be simulating oceans. You're not supposed to be doing like um, industrial light and magic level like water simulations of a boat crashing through waves. Like, no, it's MoGraphy stuff where we can art direct these and we can fill, have maybe drips go down a bottle or fill up a glass, that type of thing. um, so yeah, let's just keep that in mind. Now let's give ourselves. Andy was asking what driver I'm using. I don't even know how to look that up. I am not a hardware guy. Um, Open up a disk shape. Drop this down here. Make it larger, and we're going to right click and add a simulation. And is it just a collider? Yeah, and then is there collision? Okay. Yeah, look, there's an entire new category. You see everything's highlighted in yellow. That's new. So there's a brand new pre-process section that right now is automatically thickening the geometry, which is cool. And then we have, an offset position for the thickness. That's cool. And then over here we have mode. So right now it's calculating things as a volume. Presumably this pre-process is automatically giving this thickness. And we've got collision side, which is on the outside. Okay, that makes perfect sense. Voxelizing, relative or absolute. Voxel size. So this must be um, voxelizing this to some degree so that it can be colliding. So, and then inside we have interior voxel range and exterior. This is perfectly mirroring the volume builder. So I imagine it's using a similar algorithm. If you twirl this down, you see interior, exterior, and voxel size. So let's keep that in mind. Let's see. Oh, hey, Casey's here. We got lots of people hanging out today. So, wait, we're continuing to make this up. Let's see what happens. I'm gonna hit. Well, let's just rewind and then start again. So here's our polygons. It's not very heavily subdivided, but let's see what happens. Okay, those are colliding well. Nothing slipping through. And now let's take a look at the behaviors that we're getting. Ooh, and look at this. Look at this beautiful particle edge that we're getting here. That looks great. Blop 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 blop. Yep. So that's that surface tension. So yeah, this is straight up out of the box, and we are getting a beautiful looking puddle here. Now I just give us extra frames. Let's see, what types of settings do we want? Here's a density. Um, here's liquid contribution. So let's go to 50%. Those edges don't look quite as nice. Let's go way down. And yeah, now that I've gone down, you can see it's slightly reacting, but suddenly, oh, look, the particles are flying out further. These aren't gooping as much. If I crank this back up again, now it's back to being liquid, and suddenly that hole disappeared. So, we can apply this to whatever degree that we want to. Let's keep that in mind. Let that reset. Density. Well, that's mode. Mode is liquefy, and then we have a set properties, and then a unliquefy. Okay, I have no idea what those means. I'm curious to find out. Let's see what density does for us. I will drop that by 0 and see if we feel any change. I mean, those on the outside definitely feel different. Let's drop it to 10. We're just trying to get behaviors here. I think everything is very much stopped behaving like a liquid because now these aren't moving at all. You can see where there's a bunch of density. They're all kind of piling up a little bit. And yeah, they're layering. And let's go back to the density being back to default. And yeah, suddenly these edges make more sense. Everything's fighting each other a little bit. Maybe turn that on and off is not a great idea. Oh, look at this really nice string there. Oh, that looks really nice. So yeah, maybe that's not a good parameter to be like turning on and turning off. Let's see. Viscosity, surface tension. So yeah, let's try viscosity. So right now it's 0.1. So let's go 10 times higher. Jump this up. and see if we see a difference. So it should be 10 times the viscosity. That in viscosity, I think tends to mean like goopiness. Um, Given the current setup, maybe, well, actually, no, like there's not as much, there's not a lip around the outside now. So we are seeing a difference. And you can definitely see the particles are kind of fighting each other where they're seeming, it seems like it is trying to goop up on top of itself a little bit more. But let's withhold judgment on that. We're just tinkering with some basic parameters. Point. So now we're doing 1/10 of the original amount, and now look at that was okay. I'm not sure why those exploded, but look at these tiny little puddles. Oh, look. Okay, look at the behavior of these where it's. I know that made a big difference, and it looks really cool. Where we have all these little individual puddles, but then they blob into each other. Those little bursts when they suddenly fly out, that feels like something's not quite right. We might need to limit some velocity or something. And you almost feel like little raindrops hitting here, where particles hitting, forcing the pieces away, and before it can kind of regoop back together again. So that looks amazing. Um, let's see. I'm going to change the color of these for you right now. Does that come from the emitter? Color. Let's make them dark blue. It's liquids after all. There we go. Boom, 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 boom. Okay. So that was a little bit of viscosity. Let's go back to default. When I'm testing out any parameter in these types of scenarios, I just keep on putting everything back to default, and then and then change one parameter and just get a vibe for what these do based on the defaults that Maxon has decided look good by out of the box. So now we got surface tension. Let's say 10 times higher than it currently is, and now presumably surface tension is going to be like this outer wall. I don't, let's reset because I didn't feel a big difference there. Now they're again sort of exploding out, but now you can see these are very desperately trying to hold on to each other. So we're getting like these little tendrils. Looks pretty cool. I dig it. Let's put that back to default, and now let's try doing 1/10 of that amount. I don't feel like it changed. I guess it does look a little bit different. And yeah, this edge is not as tight anymore. You see, it looks kind of loose. Let's try this at 1/10 the amount. And yeah, I'm not feeling that lip on the edge. Yeah, they definitely are attracted to each other. They want to blob into each other, but that surface tension is not giving us too much of this distinct edge where you kind of feel like that leading edge of like a little puddle. Still looks good, but I would imagine that stuff like the density and viscosity would still be attempting to maintain this type of shape a little bit. Mixture ID, not entirely sure about that, but presumably we could make multiple liquids. I wonder why that'd be a mixture ID. Yeah, that's one I don't have a great vibe for. Yeah. I think we might need to look that up because right now I'm not getting an intuition for what that is. And then there's an ease in, and this ease in is reminding me of the way the old, maybe even the new ones have it, but the old bullet simulation has the, if you activate or deactivate simulation, that's like, well, how much of a transition is there between the current state and its non-dynamic state? That feels like the same thing to me. Or maybe more modern reference being the in cloth, if we make a balloon, there is a balloon expansion time parameter. So it feels like that to me. But what is a mixture ID? I'm not sure yet. Because I was going to say maybe it's like you make different types of liquid with different properties. But like to me, it's like, well, I don't think that's what it is, because we could just say different types of liquid are doing different things just by dropping them into the particle group directly. And now this is limited to this particular liquefy. Cool. Okay, so those are all of our constraints. Then we have collisions. So we got our interaction mass. Presumably this is how heavy is the liquid. Why don't we find out? Let's see, because I think that our simulations work with the other systems like rigid bodies. So let's make rigid bodies and soft bodies. So let's make this editable. Let's make that not a collider object. I'll make a single loop on the outside. And actually, you know what? I would think I'd like a cube a little bit, or a plane a little bit better here. T for scale. A couple extra subdivisions, nothing too crazy. Make that editable. Select all, shrink, invert, and now I have the outline. And then simulation, cloth, surface. No, not tearing. Dresser. Initial stage, fixed points, set. So now we've locked those outer ones. So in theory, that should just be cloth that's going to want to droop down. Everything's decided to run a little bit slow on me again. I'm presuming that it will wake back up again because I don't think that these should be they shouldn't be interfering too much with each other right now. Okay, now are these having an effect? Because I don't know. We might not have that might be something we need to activate. So these might be clearly they are hitting the cloth, but do they weigh anything? I don't know. So that might be an entirely unique setting that we need to mess with. So let's go back to our liquefy, and we did have interaction mass, and this feels like type of thing that would be that we are interacting with another type of simulation. So let's try making that 10 times heavier. See if we see a reaction. I wouldn't necessarily expect to see a reaction in real time here. I'm going to add another 10 to that. I'm going to add another. Still not seeing a reaction, so I'm thinking that it probably needs to reset in order to see the new number. I don't know. Let's put 1 and start this over. See if we can feel that. Well, yeah, okay. I definitely see individual polygons getting pushed down. So we're 100 times heavier than we originally were. And now we can definitely see that the cloth is reacting to the fact that this liquid is pushing on top of it. I think I'm going to increase the radius of our particles. So that lives probably under properties, radius 1. I'm going to increase it. I don't go too far, but let's say 3. That's quite a bit more volume. And the liquefy told us that changing the number didn't do it. This is just the computer. Sometimes it wants to grow fast, sometimes slow. We saw that the radius, somewhere we saw a setting. I now have, oh yeah, right there, use default radius. So yeah, that's now, these are just larger, still just as many. Blurp, blurp. I love the way they're reacting to each other. Like, that's so cool. These systems playing well together is really cool. And it is quite heavy. So, I'm thinking of this right now is like we're dropping probably heavy like ball bearings on here, and that's why we're getting all this energy kind of oscillating through. Let's see. So that's cool. Yeah. So interaction mass, friction. That's kind of self-explanatory. How much friction is it slowing down? There is stickiness. This is intriguing. I didn't know that we'd have stickiness in here. So let's try. Let's copy. I'll save the scene file and scene file. For anybody who is hanging out for the first time, I save these scene files, and later today these will be available on Patreon to anybody supporting at the engineer tier. Simple liquid on cloth. Okay, now let's copy all this stuff, new file, paste. Should be identical, but now let's make a landscape. Landscapes are good for, creating a little bit of chaos here. Exaggerate that a bit. Again, you see my particles are sometimes happy, sometimes not. So we're going to dramatically decrease our polygon count there. Right click, simulation, collider. Right now it is, as we saw before, it is automatically thickening our geometry as far as liquids are concerned. Maybe this is applying to everything. I would be curious if this is also, if this pre-processing is also there in the context of cloth. But let's just see. Okay, everything's pretty much default except for our larger radius, as far as I remember. Those are doing a lovely job of sliding down this hill. This actually feels like a pretty good demo file, or an example scene for us to tinker, because there's very much like a flow direction here, and we can see them kind of pooling, which is not something that we would have had before. Interaction mass, actually, that's pretty high. So now we're back to defaults. Yeah. Now, um, friction makes perfect sense. Let's just add in some stickiness. I imagine a little goes a long way. No, actually, that wasn't crazy. 11, 111. Nope, that almost doesn't feel like it's doing anything. Let's reset. Okay, that wasn't a reset based thing. And stickiness is just straight up stickiness, right? That we don't need the collider to be slightly sticky, do we? Like if we say 0.1. Oh, okay. Maybe they are multipliers on top of each other. So this has to be at least a little bit sticky in order for the other one to be. So I'm going to lower its number down. And now it's an interaction between those two numbers. So now I can drop this back down. And now let's see if we can get something a little bit more goopy. Yeah, immediately these are getting sticky on there, but not so much that they can't move. So now we're going to have more of a little blob flowing down our hillside here. Just for fun, why don't we try making one of these liquid meshes and see? Oh, okay. We didn't even have to link anything to it. Immediately, this is now spitting out geometry for us. Influence, scale, steps. Let's hit NB and look at our. Oh, that's interesting. It it doesn't show the polys. I hit NB and it's not showing it. Bounding box static, diamond, particle group smooth, processing, remove artifacts, export. Oh, this might be. This is probably another particle thing where this is getting calculated on the GPU. So it is just returning like a raw mesh, but this isn't really a mesh inside of Cinema. It will render properly and all that. But if we want to see it for real, we need to be exporting whatever it is for real. So if I click on export and turn on geometry, now we're seeing the real geometry that's being made of. I wouldn't be surprised if that it gives us a significant speed hit, because now it's having to probably go from the simulation engine back to Cinema in a big calculation way. Just like when you go to volume and you say export the data for real, it's leaving that really optimized environment. But anyway, I just wanted to see what the mesh density was. Let's go and turn that off again and see. Okay, maybe that wasn't doing too much of a speed hit. It's just the computer's decided to go slow right now. So anyway, that's some liquid mesh in theory. Bunch of properties, influence, scale. What does that do? It's a number one parameter, so presumably something important. Yeah, so surface offset scale. So this seems to just make everything larger. So by going down to 1, I don't know this for sure, but my assumption would be that the influence scale is a multiplier on the radius of the particle itself. But maybe it's absolute. I don't know. So let's find out. If I go back to our basic emitter and I go down to the radius, and I don't want to confuse this, so we'll just go under properties and say that the radius is going to jump all the way up to 10. And I didn't refresh right now, but new particles are being born at a larger radius. And then let's drop the radius down to 1. They don't seem to change because these new ones are born with a smaller radius. So I think that this liquid mesher seems to be independent of the particles. So that's potentially fine. Good to know. So let's get ourselves a little bit of a blob going here. Yeah, I need some more. Let's turn that off for a moment. I don't know how much calculation time that is. Yeah. Sometimes we're going to go fast. Sometimes we're going to go slow. Go figure. I just want to get a little bit of a gathering of them there. Remesh it. And now I can just zoom on up and let's take a peek at, I guess I'll turn on export just so we can see it. Let's see what some of these different settings do. So if I increase the influence scale, it just gets bigger. It's a bigger blob. So you can think of this as like an absolute particle radius, I think. Surface offset, I'm curious by that. I don't know. On a technical level, obviously that feels like it's inflating everything and it's surface offset. But like, is that just another type of scale? A theory I have here, I don't know. Let's move down into our mesh, and we can see as we increase this radius that the blob is getting bigger in an absolute way. But if we go to 1, then it's pretty much not intersecting through the mesh. And then if I increase my, oh, there's surface offset there, but if I increase the surface offset, yeah, it seems like this surface offset might be taking into account collisions, because we've now inflated. Let's drop that back down. You see that we've now inflated larger, but it doesn't really feel like we're intersecting much more. Like that's really dang close to the surface. Hard to know for sure. And it's clamped at 1. Um, can we go negative? We can't. Oh, that's interesting. It's unclamped negative, but then it just disappears. But it is clamped positive, so go figure. Mode relative or absolute. Presumably these settings tend to mean this is going to modify things that come below it. So steps, I don't know what steps means. It might be we're subdividing twice for every influence scale, or possibly twice for every radius, or a unit of radius. If we say absolute, presumably this becomes like just an, it's a simple absolute voxel size, presumably. So if I make this larger, we're going to have a less dense mesh. So yeah, this is absolute or relative as far as your mesh density is concerned. Seems handy. And if we can drop the steps down to 1, so a nice simple one. Actually, it looks kind of cool already. A nice like low poly liquid. And if we increase, we want to go easy on this, but as I keep on increasing, you see that they are, getting more detail. But I am also definitely feeling the spherical nature of them more. So let's just keep that in mind. If we make this, if we increase this influence, you see that the individual spheres will sort of disappear. But if your radius is relatively small, we're seeing every individual particle. So all these settings are related to each other. So always keep that in mind. Bounding box, static or dynamic. Presumably, this is calculating some sort of bounding box for us that we could be doing collisions off of, etc. I'm not sure if static just means it won't update, or dynamic. But then we've got all these. Yeah, this is one. Oh, a static bounding box. Oh, is this the valid calculation range for it, or is this limiting? Okay, this is limiting where the. Okay, that's really interesting. This is limiting where the liquid mesh is going to attempt to go. Although liquid simulation is going everywhere, but maybe this, maybe depending on your simulation, if you have a lot of particles, maybe that can slow it down. So we could say, no, I want to only show the voxels. I only want to like show this mesh within a certain window. So you'd be like, okay, well, the camera's zoomed in here. I need all liquid simulation, but I don't want all this mesh calculation. That's interesting. And then in exclude for particle groups, presumably. So this liquid mesh could be limited to one set of particles or a different set of particles. That just makes sense. I don't think we need to click it. Smoothing, let's turn off smoothing. And so this is more of a raw voxel mesh, kind of like the volume builder. These are very, very chunky. So then geometry smoothing is just running smoothing on it. What's interesting is that it's not doing any smoothing on these individual blobs right now, but it is doing it on this larger like collection of particles. So it might need additional information to do that smoothing. Here's the smoothing strength. If we go up all the way, then suddenly those other ones are affected by it. So I imagine this is some sort of particle density is being used to extrapolate where the geometry smoothing should be happening. So good to know. But at the end of the day, it goes to, I'm curious, how different is this if we turn that off, if we just make a smoothing, if we make a smoothing deformer, come on, I can type. Oh, goodness. Maybe I can't. Select all, SM. Oh, there we go. Okay. Smoothing deformer, drop it in. And now you can see that it's clearly different. If I get rid of that and do less iterations. So here's a single iteration of regular smoothing. And stylistically speaking, it's definitely different. This does not feel the same as what that algorithm is doing. And probably, I don't know for sure, but one of the most important reasons for them to have a custom algorithm for this, I don't know for sure, but you see, if I keep on increasing this and I make it smoother, what ends up happening is we start getting these spikes at certain types of geometry. So you get that sharp spike, but I imagine, get rid of that, go to our liquid mesh, and do some smoothing. And I'll do 100%. And this is actually still a little bit spiky, surprisingly similar. Let's try adding in some additional iterations. Oh, no, it is still quite spiky. Again, this is some combination of um, normal, smooth. Yeah, we'll have to investigate that. But yeah, if we increase the radius here, I imagine that would turn, we could get a resolution or radius that would make everything a little bit more blobby. So let's just keep that in mind. Default, default, default. Okay, so that's fine. Scroll down. Normal smoothing. I'm not seeing a difference there. So we might not be meeting the condition that is needed for that to do anything one way or the other. So we'll just put that one in our back pocket. Processing. Remove artifact. I'm not sure what that will mean. So let's turn it on. I don't see a difference. Increase. Turn it on and off. I don't see a difference. I think everything's pretty much default here. So, yep, that's just another situational thing that we don't quite know yet. And then droplet scale. I wonder if droplet is how large of a radius should be these individual particles that aren't really a blob yet, whatever that means. So yeah, as I shrink this down, you can see we can make those individual ones smaller. But the cool thing is, if you look down at our blob, that's not really having much influence on the blob overall. The blob is still just a solid, but we can make individual particles be a little bit smaller for the radius that's being calculated. Then we have droplet threshold, and let's try dropping this down. Yeah, essentially, it's like via these settings, it seems like you can make it where each particle is less than a voxel, and only once you start getting a collection of them will you start seeing them. Um, so I have a vague idea of what this is doing here, and I know enough now that if we want to, we can come back to it and be like, oh wait, something we like the part we're seeing too many of the particles, or we're not seeing the particles well enough. Even though right now this isn't having a useful effect for us, we know where to come back to and explore, including artifact and potentially this normal smoothing. Um, oh, I wonder, normal smoothing, is that going to be like? I mean, maybe it's doing. Maybe it's not a algorithm derived from normals to do smoothing, but instead it's literally smoothing out normals of the object. So like the curvature of the normals, can we see them in the viewport? Polygon normals. Yeah, this needs to be made editable to see those. Mm, yeah, I'm trying. But right now, if you imagine all those little dots kind of like facing out from, like a bunch of lines facing out from the normal of the polygon. I wonder if this is going to be blending those to look smoother on the surface. But given the setup as we have it right now, it's just not applicable to what we can visually see right now, but that's my current theory. So that's all the settings in the main tab of properties. After that, we've got what we can be outputting. Well, let's output the normal. Okay, yeah, now we're outputting the normal. And now that we're outputting the normal, I imagine that this will do something. Yeah, now if we turn this on and off, the normal is smoother or less as we increase through here. And yeah, you just see everything's getting smooth overall. Okay, good to know. If you push it really far, it's getting real smooth. Okay, cool. Well, you solved that problem, or that mystery, very quickly. Density, if I turn that on, okay, that's what I thought. We are now returning a vertex map. Okay, so this is just a black and white map, presumably. Now, we are not seeing it in real time here. I want to see if I can kind of hack it. So let's not connect. And can I add I want to see if we can just see this in real time. So, oops, if I say other vertex map, and then we link this one in, maybe this is density. Maybe that's giving us information. Maybe it's not. Right now, nothing controls density here directly. And right now, based on our particles, maybe they're all a mandatory distance apart from each other. So I don't really see a threshold there. I'm curious what that would do specifically. Um, Density. And this could go back. This could go back to liquefy, where there is a density here. So it's like how many particles are within a certain area. So something to keep in mind. Not quite actively working for me right there, but let's continue to explore. Color. Let's activate color. And now I imagine that we are getting a vertex color tag. Yes. Now this is outputting those colors in theory. So if I drag this in, oh, sorry, we got to make a vertex color map in order to maybe see it. If I drag that in, yes, they're all blue. So these are going to be the colors of the particle as projected onto the mesh. Now, there are no settings for this, but let's, for the sake of experiment, let's go into our basic emitter and load in random noises, and I'll just load in one of my neon presets, kind of a rainbow neon. And now we got a bunch of particles coming in. All of them have completely different colors, kind of all neon looking. And you can now see that those are getting translated directly onto this mesh. Well, actually, they're getting translated onto this vertex map. So we could do things with that data as a vertex map. Now, we already saw that, I imagine, if I turn off this connect and if we turn off this export, that yes, they are already that color. So it's doing that automatically for us. That is the color maybe of the vertex. I'm not sure if this would actually translate into anything in cinema. I mean, actually, I wonder if we open up Redshift right now. Oh, that's a hiccup. Oh, there it goes. Okay. If I hit go, it's not gonna look pretty, but will these render right now in Redshift based on the way they look? Okay, they're rendering as particles, not as a mesh. So this might only render at render time and not here in the viewport, unless, of course, we tell it to output the geometry. So if I say geometry on, then I imagine, yeah, immediately this turns into the real geometry. So yeah, anyway, that sort of answers that question for now. So now if we reactivate this, now we're getting these colors in, but the advantage of doing this is you saw the rough mesh had very kind of hard transitions between them, but by me putting this into a connect object, not welding, making a second vertex color map, if I drag in the first color into it, then we can do things like average them. Keep in mind there's some calculation time associated with this. But if we say 0, it's going to pretty much look the way they already do. But as we begin increasing this radius, we're going to start getting a little bit of a blur between them. So that could just be a nice way of like making that transition not quite as harsh. So yeah, something to keep in mind. And now as these continue through, I don't imagine it's running fine. So these are going to be like kind of nicely like blurring the colors between them a little bit, but that's only because of pure proximity. Oh, I'm not sure why they disappeared. Oh, that's because suddenly my video card's like, I'm going to go extra fast now. So anyway, now you see all these colors. And if I get rid of that, you see that they're all there, and they've got a nice blur between them, but they're not blending. I just wanted to mention that Noseman definitely did do this in his stream earlier. Not that we wouldn't have been able to emulate it a bit, but anyway, I'm going to make is it just blend? Yeah, so we're just going to make a blend modifier here. And the blend, we're going to say, yes, take the color and then blend based on a particular radius. And we don't need that to be much. Let's say like 3. And let's say 10%, which I think is still very fast. And now let's reselect this. So we still have that natural blur going on that we added, but now I've told the individual particles to start taking on the color of their neighbors. So as these get close to each other, they should become over some frames. Let's let it go. And we might need to change a couple settings, but if I let this go a little bit, and keep in mind, we're getting new fresh colors in constantly. My radius, I thought it would go a little quicker than it is. I thought it'd go very fast. Are they blurring? Are they not? Let's crank it. I'll increase my radius to 10. And even at 10%, I would still think this would take like maybe 15 frames until they're a uniform color. Yeah, seemingly. Yeah, you see, they almost feel like they're turning a little more gray. And I think given enough time, these particles in proximity to each other. Actually, now that I think about it, how large are our particles? Oh, yeah, radius of 5. So yeah, there's not very much overlap here. So yeah, I've been being not very generous to our radius here. So yeah, as I increase this radius, I imagine the quicker that this will sort of become more uniform. Even down here, you see the kind of the slightly more uniform blurriness where we get these new fresh ones coming in up here and the colors are very heavy contrast. So we could push this, further and further and eventually get them to be kind of completely blurring and merging in. So yeah, that's cool. Yeah. Now it's definitely heavily blurring. They're blurring quite a bit even before they get down there. So you got to find the right mix and match of that. Yeah. Anyway, that was just that's just that one data type. I suppose I'll save the scene file. Why not? Simple liquid meshed blur. Cool. Okay, now we're pretty much just stepping through settings. So that's color. Then we've got velocity, which is intriguing. If we activate velocity and we don't see it again, and this is a vertex color map. So now just for us to be able to see it, let's drag it in. So now it's showing us in real time kind of what it's outputting. To my knowledge, I don't know this for certain, but is velocity just the speed it's moving? I'm pretty sure a setting like this is for the purposes of motion blur, that maybe Redshift can read this data and be able to blur the liquid sim, not based on the mesh, because the mesh is completely unique every time. So you can't blur between this point used to be here and now it's here. No, the point's just gone and it's rebuilt from scratch. So this is more like, well, here's the raw point information at any given moment of how quick the particle's moving, and then that gets translated into Redshift so that it can blur. I don't know that for sure, but I imagine that's what's going on. Yeah, so that is all of the settings inside the liquid mesh. We don't know what all of them do yet, but we know what most of them do. Okay, cool. Let's move back into liquefy. We now successfully have stickiness going. We got damping. Damping just drains energy out from them every single frame. So that's a good setting to have. Yeah, but because if you remember some of the early unified simulation system, we didn't have damping per object, and you just had to do the universal one, which was like that drove me crazy. So I'm so happy that we have damping on individual objects here. In this case, the liquefy modifier. Let's see, and then potentially we could put a lot of damping in there and get a very viscous looking liquid just from that. Now, essentially, we can start doing some experiments. I will turn off this mesh for a little bit. And what I'd like to do is see if we can get a little bit of a blob going. Right now, it's all been very runny. And I want to see if we can get a little bit more of a blob going just from this same kind of emitter setup. So let's move into liquefy. Well, actually, we do have more properties. So maybe before we start trying to art direct something, let's see what our options are. So under set property. Oh, that's interesting. Set properties. Unliquefy. Set properties. Liquefy. Okay. This is sort of, this almost is acting like on, off, and the set property. I don't know for sure. This could be an optimization. A lot of these are guesses, and I'm not looking at any documentation. It could be that the reason I kept on having to reset when I changed these numbers was because it was like, no, this only liquefy is like, this is what's going to be always. Maybe set properties means it's refreshing every frame and sending that new information over to the simulation engine. No, I guess not set, because right now there's nothing happening. They're not liquid. Oh, okay. So I do that. And now if I turn on set, new ones keep going and the bottom ones don't. So that's also kind of acting like, is it on or off? Set the properties. Yeah. Yeah, I'm not 100% sure on that one. And then, yeah, unliquefy meant the other one's probably also turned not into liquid. Not entirely sure, but I have a vague idea of what it might do. So if we need to explore that aspect of it, we can. What was the final liquid object? Liquefy. Oh yeah, the liquid emitter. So Let's before we go any further here, let's try playing with the liquid emitter. Let's get rid of the blend. All the stuff is turned off. It's fine. So liquid fill emitter. It wants geometry. Okay, fair enough. And then sphere packing grid. The resolution is based on the simulation scene override. Okay, so let's start out as simple as we can. We'll make a sphere. So here's a sphere. I'll scoot it this way a little bit so most of it wants to go down the hill. Liquid, grab the sphere. Actually, I will say don't render, and then I'll say render tag, display, use, lines. So now we can see the shape, but we can see right through it. Let's let that run and see what happens. Boop. Okay, so the instant we let that run, now you see that it is via like a actually no sphere packing. So a sphere packing algorithm. Little hard to see. Let's delete that. Turn this. Increase our radius up to 3 again. Yeah, so sphere packing I think means that we're going to get a triangle, and then the next layer of triangles are going to be above the center point of the previous triangle. Anyway, it's and I mean honestly, this is behaving in a lot of ways like the just one of our like our geometry. If we do a mesh emitter, then we could do it from a volume. So this feels very similar to that, except we have some additional algorithms like the sphere packing and a bunch of stuff here. So we're going to see what the other settings are. So yeah, sphere packing. If we say increase that to grid, pattern grid, sphere packing, the resolution is based on the simulation scene, but we could turn that off. And now let's give us a distance of 10. So now you can see I was able to space those out more. Or if we say it's based on a simulation scene, I'm not sure exactly what setting that's going to be looking at. Maybe there is a universal setting, or is it based off the radius of the particles? Maybe the radius with no variation taken into account for. I'm not sure. But anyway, yeah, that's how we can customize the density there. Sphere packing is probably going to look a little bit better for liquid because it's less sort of uniform. So yeah, there we go. We get a big blob. And now this big old blob, which is a full volume, can strike. And ooh, that looked great. That was really cool. And now my computer's like, yeah, let's go super fast. Oh, look at that tail on there. That's great. Wee splash. Yeah. So many little properties here that we just wouldn't have had before. All right, let's tinker, liquefy. Now let's try and make it more of a blob. So I'm thinking lots of viscosity, and it's currently set to be pretty sticky. But honestly, let's make it 10 times as sticky. But keep in mind, not many particles are striking the ground. So only those ones that strike the ground, I imagine, are going to be what's really getting stuck. Blurp. Splash. Now, as it spreads out, maybe all of them will slow down quite a bit. Although, we still have a little bit of stickiness there. I'm just not feeling the stickiness like we did before. Stick, dang you. Nope, 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 nope. Very sticky. That's all we did before was some stickiness, right? I mean, I know it wasn't on the liquid fill, but why would that make a difference? Everything is getting applied everywhere. This is applied to everything because it's not in the group. There's a lot of viscosity. Maybe that makes a difference. Blurp. That didn't really feel like it makes a difference. All right. Not sure about that stickiness. And I was going to say, well, we can't just ignore it because our current experiment. Oh, they changed the icon for that. I'm glad they changed the icon for this. I could never figure out what setting contained these, and that looks like a little very old school camera like bit of footage, but I like that. Let me think. What is different here? What is different? Turn those off. Basic emitter. We didn't really change the basic emitter. Maybe we changed the radius a little bit. Yeah, look, those are just stopping dead. Like, definitely got friction here. Okay, so those are definitely stopping, and that it's very very oozy. Now that's getting the exact same properties as this liquid emitter. The liquid emitter comes with its own properties. All right. The liquid emitter is doing a lot more. Okay, this is maybe making this liquefy make more sense. This set properties because your liquid. It looks like all of this information about all of these is not stored inside of the liquefy, but is stored in the particles. So when you make a liquid emitter, they are instantly given all of this data, and this is the information that they're running through. The liquefy is going to assign the data, but it's only going to assign it when you're in liquefy if there's not already data. If there is already data, I imagine set properties would override it. So does this mean if we turn off liquefy that these are already behaving like liquid? I mean, they're already falling. So yes, the answer is yes, because particles aren't affected by gravity. So yeah, a liquid emitter is within itself a liquefy. Okay, that's something very important to know. Splash. Okay, cool. Very good to know. So stickiness added in there. And now those should be goopy. I'm glad we started with something so blatant because I could have been changing like the viscosity and that would visually be so much more difficult to realize that it wasn't quite working. It'd just be more visually subjective. Where stickiness is very blatant. So anyway, we lucked out. Okay, yeah, that slows down super duper slows down. Now, how do we make these? It could, I mean, gravity is having a major effect on this. Most of that stuff doesn't matter. We're just getting this target density, viscosity, surface tension. Let's try increasing the viscosity and surface tension just to start out. Immediately, the entire blob definitely felt like it wanted to cohere a little bit more. Blurp. Ooh, okay. Not bad. Immediately, you can feel, oh, look at the blob. That's so good. Look at it rolling down the hill. Oh, this is so good. Okay, particle group. I already made the size larger, but let's increase them even more. Look at him walk along. It's like a tank. Yeah, rolling down the hill as a big old blob. I mean, that's almost, I mean, just we changed two numbers. The two numbers I was guessing that is like maybe, and I could be wrong, but I was kind of guessing that viscosity and surface tension kind of work hand in hand. Maybe they do, maybe they don't. Let's try returning our surface tension to something lower. And maybe it's just pure viscosity. Yeah, viscosity. Like I said, I think viscosity is like the goopy setting. Okay, let's try doing 10 times the amount again. Okay, yeah, there seems to be a limit here. If you push it too far, you see that this is not better. And in fact, it seems like they're pulling on each other so hard that they're kind of breaking. Let's try adding some surface tension on as well. Let's try doing equivalent surface tension just out of curiosity, seeing oh, okay. That so again now again I'm trying to operate on like do these what's the relationship between these two things, and here you definitely see that by adding surface tension in that the viscosity is pretty good. It's still a little bit jittery. I mean that's just it just is what it is. It's going to be jittery. um but that's pretty cool. And I mean, keep in mind that these in theory are just particles. Let's calm those both down a little bit, not so jittery, but these in theory are just particles. So even though this is supposed to be a liquid simulation, and it is, I think I should be able to just make a cloner. Let's make a sphere, drop that in, and we don't need, I'm going to do a few segments and still make it kind of look like a sphere. Clone onto an object. The object will be our particle group 1. And I want to take on the particle scale. And that means the sphere should assume that the radius is 1. So now I can say, put the radius back to default. And now this is returning as a group of spheres. These are just spheres rolling around now, doing their thing. So now we don't need to do remember in bullet simulation that we often would try and fake a very low resolution simulation using the force field and a bunch of spheres. But now here we are essentially getting the same result, but just the liquid sim is doing all the work for us. I do feel like these two settings are probably well. Actually, let's not make any assumptions quite yet. Let's grab this cloner. Say it's a multi-instance. That should speed that up a bit. Now, you see those are quite jittery, and maybe they will always be jittery if we put higher settings in there, but we have learned in the past that if we hit Control D, simulation, particles, that we have substeps, and stuff like the predator prey and the flocking, when we did really high numbers, they would sort of freak out a little bit. But as we added additional substeps, it could clean it up quite a bit. So it's not a guarantee, but now if we hit an extra substep and we run that, is this going to be less jittery? That's the hope. I don't know if it will be. And then we can go up a couple on here. So let's increase it again. And let's start it again from scratch. It looks like, at least in the viewport, this cloner, at least at the multi-instance, runs one frame behind the particles. So just keep in mind that that is not perfect one-to-one. It's hard to tell. It feels a little less jittery, but it definitely feels jittery. And there maybe there are some sub steps that would help that, but I don't feel like it's making that big a difference right now. But we'll keep that in mind. It's another tool in the toolbox. So yeah, lovely blob right there. I feel like we're getting a pretty good grip on the basics here. So I haven't been paying any attention to the chat, sorry, but we might be able to start trying and do some specific things. Lignazio, thank you for subscribing for the 38th month, which is amazing. I can't believe I've even been doing that much live streaming. I haven't said it. Actually, Lignazio, do you know if does Twitch still have like those free subscriptions if you have an Amazon account? Anyway, if you're on Twitch, you might have a free sub that you can give away. So you can kind of do that for free if you have an Amazon Prime account. Anyway, scrolling back a little bit. I mean, a lot of these comments are going to be back when I was doing earlier stuff. Casey's talking about some of the technical stuff here. Maybe Casey was active in the beta. Slimy drips. Somebody's asking for maybe some slimy drips. Potentially we could experiment with that. Yeah, mesh exported. Thanks, Casey, for trying to guide me, even if I wasn't reading it. Is it not liquid substeps? Weren't we in? Is there a liquid substeps? Just Casey, you weren't here in the very beginning. I literally haven't played with this, so this is my first actual exposure to it. Oh, there's a whole liquids tab here. Yeah, I didn't even notice I was being blind. So it looks like, yeah, there's the radius, neighbor passes, extra iterations, viscosity iterations, surface tension iterations. Oh, wow, okay. So yeah, completely separate settings to do here. So let's see our jitter. I wonder if those particle ones were doing anything. So have a lot of jitter, but now we have just straight up extra iterations. But specifically, let's try our viscosity. Oh, wow. Okay. I just did one and tons of the jitter went away. Let's do another one on the surface tension. Oh, look at this lip trailing behind because that's where the friction is really high and the rest of them are rolling. That's hilarious. Let's try 3. 3. Oh, interestingly, 2 looked great. Look at 2, super clean and stable. I'm going to increase it to 3. Oh, we ran out. Let's go back to 2. I'll go back to 1. So now we have super jittery. Let's go 2. Pretty dang nice. Increase it again to 3. It's more jittery. Go figure. It could just be like that particular combination. Extra iterations doesn't seem to mean anything here. Neighbor passes. That does. It kind of felt like it was doing something, but maybe it's not. Very, very hard to A/B test these things. Let's try continuing to increase. So yeah, that's interesting. 2 passes smooth, 3 passes more jittery, 4 passes more smooth, 5 passes more jittery. So for some reason, every other viscosity iteration is helping or not helping. And now that we're all the way up to 6 iterations, that's looking kind of wacky. There's like all this structure sort of happening. Not quite sure what's going on there. Let's increase the. Now, if I increase the surface tension back to 6, that seemed to be an interaction between the viscosity and the surface tension. Um, and yeah, I'm not sure. I imagine I am right now. My thought is that you want to keep these in relation to each other in some way. So because this went up one level, the surface tension was okay. It's weird, but here's what I think is happening there. That's why we're seeing jitter on every other one, was because we have a lot of viscosity and we have a lot of surface tension. As I increased the viscosity, let's go back to like 2 and 2. These are both on par with each other. But if I increase this, the viscosity is getting it's getting an extra calculation in there, and essentially the viscosity and the surface tension are out of sync with each other because they're getting different number of subframe calculations. As soon as these, you see right now it looks jittery on 3, and we're like, oh, why is it every other? But I bet you if I increase surface tension also to 3, that it'll go away. So yeah, it's better. It's still a bit jittery there, but I think it's more than anything a relationship between these two things. Like I wonder if they're multiples of each other, that even that would be more stable than if they're not. Anyway, that's my current theory. Now, considering here, so backing up a step, here we got a bunch of viscosity, a bunch of surface tension, and we've added a bunch of iterations there. I have to say, I am very impressed at the extent that this wants to stay a blob right now, because we have not decreased gravity at all. Gravity is still full power on these things, still pulling down so much, where I was making the assumption that if we wanted to make these look more blobby and be stable, and this still could be a good tool in the toolbox, that we would need to lower the gravity. So let's do that. Let's hit simulation or scene, and here's our gravity. So I'm going to drop it to only about 200, and let's see what changes now. Blah. Okay, so now with less gravity, you see it's not a perfect sphere, but it's more sphere than not. But the fact that with full real world amount of gravity, that it was that much of a blob, like that is some crazy viscosity. Back to liquids. If we put these back to 1-1, it's still crazy high, so it's not. But yeah, with less gravity, you can still see that that's doing pretty well. But actually, and this is pretty important, you can see that if we run the simulation with viscosity iterations, or both of them with their iterations low, that this kind of it blobbed down a little bit without changing gravity, without changing the actual viscosity. If we say actually it's going to be up at 6, look at like obviously more calculation time, but look at how much more it is a sphere just from the iteration count. Like look how little that just collapsed in on itself. So this iteration count could be almost as important as the actual viscosity and surface tension by themselves. So anyway, something to keep in mind. I might go to 2 and 2, so it's a little bit better than default. Let's do it a little bit better than default, but let's keep that in mind as we play with settings, that we are not default in our global setting, which is of course the most important of settings. So just out of curiosity and fun, let's drop our viscosity down and our surface tension down. And again, you see it didn't feel like these properties really updated. Casey, do you maybe know anything about that? That is like I just lowered these down quite a bit and go back to default, and they don't seem to have that property unless the scene gets initialized at frame 0 with them. Are we not? Is it not possible? Maybe it's not possible to modify these, but we could set a condition, and that's where the liquefy comes in. We set the properties where it's like, oh, it's met some new condition, and that new, yeah, Casey says you cannot keyframe them, but we could make a liquefy, set a different property, and we say, well, given it passed through this, or given that collided with that we could then be like, okay, now change your property. Now you are a different type of liquid. So yeah, it is true. I can't just change that property and suddenly our big viscous ball is going to turn into a liquidy goop. But let's see, let's essentially try and do what I was just describing. So what I think this was at 5 and 5. No, what was it at? Let me hit undo. It was just 1 and 1. Okay. Was it just 1-1? Oh, it's 5.5. Okay. So I'm going to make another liquid, and everything should be defaults. So this is now a low viscosity. Um, I'm going to put gravity back to default as well. Boop, default gravity. Okay, so we've got liquefy, and we're going to say it's going to set the properties. Okay, yeah. See, this is where it goes to. You saw I didn't go and immediately like read up the documentation or anything. We saw a parameter liquefy set properties unliquefy, and we were like, well, what are these doing? I don't understand. But it's like in my head, I was like, well, I know that's there. Let's keep playing. And as we kept on playing, we've now realized what that property did without us even having to look anything up. Anyway, I want to drop this down as this pretty solid blob. And then, yeah, let's say right around frame 50. So we'll make a condition. And the condition will contain this liquefy. And we'll say, do we have just lifetime age percentage? Maybe just age. Age is greater than 50. Then they're now going to take on the properties of this liquefy, which should go from a viscosity of 5 down to 0.1. So let's just see what happens. Okay, and it's a couple frames yet until 50. Should have done a little bit earlier, but we're too far in. We can't go back. Okay, right around now. Oh, I didn't turn on set properties. Dang it. Okay. Let's say, we're going to do this earlier. Condition frame 25. Okay, now we are not initializing the boom and blurp. Okay, there we go. So that's how we can change the properties. Now, keep in mind, I just said to do it on a time, but this could be via so many different things. We have so many different types of data that these could be kind of like transitioning between. And then didn't we also see, maybe not. Oh yeah, so we got the ease in. So yeah, how many frames does it take for them to ease from one thing to the other as we jump from one property to the other? At least that's what I'm guessing. So if we say it's going to take 15 frames, let's see. Well, that felt pretty dang quick to me. Let's try one. Maybe this ease in is just mixture ID. Blurp, blurp. Yeah, those don't feel different. So I'm thinking this ease in is about a mixture ID. And now my assumption is that is there an ID here? Somewhere we can probably set different IDs, and then this could be switching between like these universal liquid types. I don't know. Output properties, liquid contribution, lifetime, velocity, color, not draw, born, emission. I'm not seeing it. And it seems like it would just be an int somewhere, that there'd just be a straight up int. But mixture ID. I mean, this is maybe this is us giving it the ID, but the ease in just didn't seem to be doing anything. We'll try running it again. So at frame 25, it's going to go here, but I'm saying it should take almost 2 full seconds to transition. It's very hard to tell. Now we are dropping like pretty dramatic numbers there. I just want to I'm gonna give it like 400. It's gonna take 400 frames to do the transition, and let's just see if we feel the transition at all, or is it just like popping from one to the other? I'm sure there is a way of doing this, but with a property like ease in, like that must do something. We just might not be using it right. So now we're on frame 25, so it should be transitioning, and yeah, immediately this just feels like it's falling apart into the other property, actually very differently. That's kind of weird. Yeah, I don't know about that. Very strange. Anyway, we have definitely learned more that now we know what set properties and liquefy means. Liquefy means take a particle that did not have liquid attributes at all and give them the attributes of what this is. when you make a liquid emitter, it can also immediately be given, or it is automatically given, all of the liquid properties. And then when we are in set properties, it is now taking on these new properties. In theory, there's some sort of transition there. And then if you had a liquefy set to unliquefy, then suddenly it's just turning back into a regular particle and there is no liquid applied to it at all. Group ID. Group ID. Is there such a thing as a group ID? If there's a group ID, is that only like in a node context? I don't think I've ever done group IDs because I don't see a group ID. But yeah, Andy, if you know. Let's see. Oh, Phil's got one that we definitely have to try. I think, I don't remember, but a few months ago at NAB, I think they demoed a quick, at least maybe even a video or opened up a scene file where they had a solid object and then it melted. So we can imagine this being like an ice cream or something made of wax and then making it look like it's not liquid and then slowly become liquid. So yeah, let's 100% try that. I still like us being on this little mountaintop, but why don't we try and grab how complicated of a mesh? Let's let's not go too crazy, but we'll grab one of our old animal friends. Let's see. Let's start with the elephant, but what other critters do we have? Anything a little more blobby? No, the horse is the most blobby of all, or the elephant's the most blobby of all of them. So let's just drag him in. He comes in huge, no eyes, yes, body, T for scale. I don't want us having a million particles, so I'm going to shrink him down pretty far. He's going to lose a lot of fidelity. Let's keep that in mind. He will steal this tag. We don't need the sphere anymore. We will have our liquid emitter be looking at our elephant. Sphere packing, yes. And liquefy. So this is a liquid fill emitter, but it comes with all properties. Can we not? This comes with the properties already. That's interesting. I mean, maybe Max, I made that to make it simple, but if we make a basic emitter, if we say volume, grid and random, yeah. So that's actually interesting that they're not uniform like that. So I guess my question is we can override it, but is there a way of doing a liquid emission, liquid contribution? We could say 0%. So okay, so they take on all these regular viscosities. See, this is a little bit tricky because if we can't transition between properties, they're not keyframeable. Liquefy. I'm actually curious. Yeah, see, these do have keyframes, so I'm surprised they are not able to be keyframed. Because you see in this liquid emitter that they're not keyframeable, which is kind of weird because you would think that these would be keyframeable because this is just what they look like at the moment that they're born. But I guess they get initialized. This isn't a constant emission. It's a static emission, which is another difference between it and the mesh emitter. Sphere packing, yes. Output, liquid contribution, 0. So it's the volume. It's sphere packing. And then we will, here's the initial stickiness, but essentially we will just activate this liquefy via some condition, and this will say, yes, you have a bunch of liquid contribution. We'll put our tensions back up to 5 because essentially we're just saying, yes, your liquidness is getting activated. We will set the property. The condition will probably just be a field condition. And right now we've got some threshold. We'll say it's going to be based on the sphere, but I'm going to leave it completely outside right now. So essentially, this is never activating. I don't think it should be activating. Let's just see what we get. Boom, we have a bunch of particles. Nothing's affecting it one way or the other. So that's fine. Now, the liquid fill is based on the simulation scene resolution. What does that mean? Liquid default, is it based on this default radius? Is that what that means? Let's do 1. Yep. Okay, so that's what that does. You know, see, I've got way more of these. And let us keyframe. Yeah, let's see. Fall off. That's probably fine. Let's just do a really blatant keyframe. I'm just going to make sure it's real close. Even now, it still might not activate right away because we got some threshold to worry about. Spherical field, keyframe, keyframe, keyframe. Right around there. Nice. And now we'll just have that. I'll even have it stop like right around there. Keyframe. And did those did, okay. Right click, key interpolation, linear. Okay. Rewind. That this is now just a condition saying once you're inside the spherical field, take on the properties of this liquefy. So let's see. Now keep in mind the threshold is at 50%, so it might need to get to around here before anything happens. But let's feel like we're starting from the butt here. Am I aiming too high? Did they fall asleep? That didn't do anything. Liquefy, set properties, liquid contribution. Maybe liquid contribution. I don't know. Field condition, spherical field. Tolerance should be fine. We could even lower that, I think. So now it would trigger pretty quick. Still not anything. Particles like this don't fall asleep, right? I don't think they do. Yeah, I don't see any sleep parameters here. This condition should be affecting everything. It's not a child of something that would be excluding it or masking it from it. Yeah, I distinctly feel like that should be doing something there. Delete those keyframes. Place this right there. Let's just see what this does. Nothing. Let me think. Field condition, combine and threshold. Yeah. That's going all the way through. So no matter what, that should be getting affected. Turn off that cloner for a moment. Yes, actually, even here, you see this field condition is saying that that condition is true. This is a true condition. Those are all getting activated. So I wonder if this liquefy liquid contribution doesn't do anything. Like maybe the slider is not one of the properties that we can transition between. It's the only thing I imagine because right now we're saying 0 liquid contribution. If we put this up, everything's liquid. But now how can we stop that from, I mean, we can do sorts of freezes and whatnot. Velocity, that's all fine. I guess I'll just make a new condition. This feels a little bit weird, but I'm gonna make a new condition. And this condition is gonna say when the age is 0, get a liquefy that will unliquefy it. So this should essentially I want to make this nice sphere packing, which is why we're still using a liquid fill emitter. And I'm immediately removing all the liquid properties from it. So this condition should be met like pretty much immediately. Okay, interesting. They're still moving. Maybe even in that single frame, they were a liquid. And we did shrink our radius. Is that doing anything? Liquid fill. Well, this is based on the scene. And then our liquefy. That should all be based on that same thing. What I'm thinking is that they're getting a little bit of initial motion, and that motion is just carrying on as a regular particle system. So we're going to add in a math. I'm going to say velocity, and the velocity of x, y, and z will be assigned a value of 0, 0, 0. So I'm saying don't be liquid and stop any movement you're doing. But this is only happening, when the age is equal. Burp. Okay. Seemingly, yeah, the theory was right. But everything seems to have unliquefied, but now we've got this other condition that's saying, yes, these are turning back into liquid. Maybe that unliquefied and then these met the condition already. Is this constantly running? Hmm. Andy's saying set the first to liquefy. I think you only need one under the field condition to set to liquefy. Only need the one. I don't understand. Everything I'm seeing right now feels like it should be working. That's the field condition. And then in theory, this is constantly getting sampled. That's losing it. Oh, maybe because it's set properties and there is no liquefy right now. So we need to initialize them. Yes. Okay. So you can't set the properties of something that doesn't have properties because we removed the properties. Okay. Now we're back to it working. I will reactivate the cloner because it makes it much easier to see. This is just for some testing purposes. We'll make it look like liquid in a moment. Anyway, that is suddenly turning into liquid. Let's go back to this being keyframed. I, I, I do feel like there would be an easier way to stop the liquid from being liquid in the beginning, but maybe this is just the nature of a liquid emitter. They're trying to make it easy for if a new user wants to make a liquid, they can just make a liquid emitter, link it to an object, boom, it's liquid. They don't have to think about it. Now I'm already in theory using it in a slightly hacky way because I just want its distribution. I want its pattern here, but I don't want the liquid. So, okay, cool. Now we got keyframe of this spherify. Keyframe, scoot, scoot, scoot. Something kind of like that. Try to leave a little bit up there. And try to make it look like there's some structure to it. Keyframe. Okay, now let's see what that does. Oh, come on. Why not? Wait, I don't understand. Why did that work? Oh, to 1%. I need this to be really up high. Okay. Okay, the threat, I lowered the tolerance, but I really want to increase the tolerance. Okay, so now we can see each of these light up on the frame that they are becoming accessible, and it is converting to liquid, and now they are like blobbing and falling down. Now, what I would love to do, what I'd love to do is control, but there's no vertex maps here. That's gooping really fast. But what I'd love to do is have this be a little bit more organic. I want to transition. Oh, Andy seems to think that we don't need that one now. And I could potentially, maybe I had some other thing I was doing wrong where we just need our initial thing to go back to being zero liquid. Yeah. Okay. So that's not needed. I must have been missing some condition here. I was messing up. Maybe we were like on set properties and we need to be liquefy or something like that. Um, blah, 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 blah. Okay. So is how can we make this essentially do this, but I want it to be more of a transition here. You can see that it is slowly happening as we pass our field through it, but I want to modify the velocity. But because we can't transition, like what I'd really like to do is have the viscosity constantly change. So yeah, for Andy or Casey, who definitely know the liquid system better than I do, because you've now seen me gain an hour and 30 minutes worth of liquid system knowledge live here. Um, is there a way of doing a more dynamic transition here? Because we could do things like I could be putting all sorts of conditions and modifiers here to be slowly like increasing the velocity, so we could make it go very slowly, and it gets older, it could move faster. But is there any way that I could be like slowly increasing liquid contribution, so that they start out slow and then keep on going? because I don't want to make a series of field conditions that are each on a different threshold and each have their own liquefy, and we're slowly going through a bunch of increments. The data mapper. Is there a custom property in the data mapper? What would I don't like if we're fully making a liquid contribution. Oh, okay. Under custom properties, where are these coming from? Are they coming from? Doesn't output? No. Don't the modifiers usually give us a list of custom properties that we're getting? Maybe that these are just being treated as new universal ones. So now we have a data mapper, which is universally applying all of these different properties. So if I set this to field, we drop the field into the list, and the property, no. Oh yeah, so we go to custom, we grab our, let's try liquid contribution. The lower is 0, upper is 100%. And now in theory, we don't even need that because that's not doing anything. So this is just a data mapper that's not using the spherical field, which I should make sure I have on. And now we're remapping these values. Maybe. Yeah, let's just see what happens. Okay, good. I'm seeing a little bit of movement. Maybe it was as simple as that. So I just made it way more complicated than it had to be, but the data was hidden under custom. But now we can see these slowly transition to having more or less liquid. The way that's moving there is very strange. I think as it become liquidy there, because of the very high viscosity, they're trying to like merge. And then it's kind of weird that these are getting flung away. They're very little liquid, but I really don't feel like those should be getting like lifted away. Um, Actually, yeah, we don't. This is not very high viscosity. We turned off that setting, so this should just be default liquid settings. These are just like, oh wait, those are high. Let's try putting that back to more defaulty looking ones. And then given what we're doing, we can drop our iterations back down again. Okay, so slowly getting more liquidy, and now we have a more reasonable viscosity. Now it's like an anteater slash elephant. Yeah, that looks a little bit better. The stuff is not flying all over the place, and this liquid is slowly getting more. Now, something we'd have to do is, oh, I didn't think about it. This makes sense. This makes sense. What's happening is, as we pass through, they're getting a certain value applied to them, but then they are escaping. And then they're leaving the field, and that means they're losing their liquid. So they just keep on flying away. So now there's just particles with no collision. That makes perfect sense. So we need to lock those in. Presumably, the data mapper with a field could. We need once something starts. I guess it could re-solidify, which would be maybe kind of cool. Um, but if we put a decay, and I set it to like I don't know 95%, then now whatever liquidiness it has, it's going to fade out very slowly. Let's see. Okay, yeah, let's just see. I've got quite a few particles here. Maybe we can drop our resolution down so it goes a little bit quicker. Or I can do some, try and apply some witchcraft to the machine and see if it wants to go into speedy mode. Um, Now, those are still getting some value and falling. So it does very much feel like they're falling through the ground. Um, some are colliding, but some are losing the value. We could keep it maximized. If something is only partially, if something is fractionally liquidy, does that mean that it's fractionally colliding with the surface? That would be strange. Um, we could, we got this data. We can map the data. We can remap the data. Vertex maps. We could. what would I want to do? Yeah, we could switch groups. We could switch groups, and then based on, yeah, what I wanted to do is also potentially, like, it's like it heats up, but then we could potentially cool it down as we keep on going. But switching groups is not a bad idea here. Where, yeah, let me show you. So we're gonna reconfigure this whole thing. Let's simplify a bit. Yeah, we don't need any of that stuff. Clean up. Okay, so we are going to make a switch group, which is just a full on condition that we can make, or it's not a condition. It's a modifier. So I'm going to say that we're going to switch a group. We're going to switch the group. Oh, that's an action. So we need a condition. So the condition is going to be a field condition, and the action is going to be switch group. It's going to switch to a different group, which we'll just duplicate, and we'll just call this group 2, or let's call this group melt. And that the switch group will switch us to the group melt. The field condition is going to be based off of the sphere. Once it is now in a new group, which is this group here, which I'll just move to the bottom, I'm going to say that there's now a data mapper, and the data mapper is just always getting applied. If you're in the group, you're getting data mapped. So, and the data map, yeah, this is actually, yeah, the data mapper is just a property now, which we are just setting. Now we should be able to remap this with time. But right now it's just activating. So it's going to suddenly be full power. So we have to remap this to sort of fade in via some property. But let's just confirm what we've got right here. Feel like we in, out, custom, it's liquid. Oh, we didn't set a property. They are switching groups, which means, yeah, they are successfully switching groups, but the data mapper is not on here. And it's not on because we are property out controlling liquid contribution. Here, we just need it to be given something. So, I guess we could set it to age. Hang on. I gotta go check the door real quick. I'll be right back. Apologies. I'm gonna click on this. Be right back. Okay, so what are we doing now? Okay, so now we've got the age, and I think maybe I will use the age. We could do this with a bunch of different things, but when the age is 0, and then when the age how many frames? Let's say it's going to take 2 seconds for the transition. So we're going to say when the age is 0, it's going to output 0 liquid contribution. When the age is 60, it's going to be 100% liquid contribution. So right now, when this field condition switches, it's already aged a bunch of frames in theory, a bunch of different frames. So what we can do is make another condition, which is going to be a simple math. So I'm going to say when this condition is met, before it switches groups, we're going to take the age and assign a age of 0. So we've reset the age to 0 in the moment it switches groups. And once it switched groups, then now it starts getting data mapped based on that age that we just reset. Now and then maybe let's change the color as well. Actually, oh, you know, it'd be really nice. Let's make a color mapper. And the color mapper is going to be essentially based on that same thing. So I'm going to say we're going to remap the age from 0 to 60 from, I guess the color is, it doesn't make too much sense to go. It's not like the wax is going to be glowing red hot. I guess we could say that this is some sort of metal. Yeah, let's say he's a metal elephant now. So we'll start from this dark desaturated gray, and then it'll start glowing red slowly, and eventually we'll go to yellow, and it will go all the way up to white. Oops, I don't know how I did that. Okay, cool. So those are now just the colors of the particles. And I guess if they're going to start moving, they would change color immediately. And then can I copy that color and just say that the initial particles properties paste. Okay, it's going to start out that gray, and then in theory, it's going to transition the colors. Let's just see what happens. And then this cloner is not seeing both layouts right now, so I'm just going to turn that off temporarily. Grab both particle groups, tell them to display 5. Okay, not much happened. Field condition. This field condition is applied to everything. I need to apply this only to the first group. Okay. So now, once it's out of the group, what's happening is a spherical field and everything was constantly resetting the age. It's always happening. So now it's not always happening. Okay. Not bad, but I'm still a little. Why is that happening? Why are they going wee off to that side? So I'm just thinking the liquid contribution is a little bit brute forcey. Both of these, they have different properties, so we can increase this up to like 200 frames. Want it to heat up a lot slower. But yeah, that liquid, yeah, it's heating up nice and slowly now. But yeah, those flying away, a little bit trickier. So what are they already pre-colliding with each other? Does it need more viscosity? Does this liquid contributions already at 0? Density, viscosity. Is there a better property? Because we could say that there's no gravity, but they're already liquid. Yeah, I'm not. There's a bunch of potential things there. Andy or Casey, do you have any suggestions as to why I'm getting the, essentially it's kind of the rig I want it to be. There's more I'd like to do, but why are we getting that burst of particles? And at different times, it's been at different places. So I'm thinking, and then actually, interestingly, these are still passing right through our collider body. That's still a collider body. So if something is not 100% liquefied, does it not collide with things? Like there seems to be some pseudo strange reactions or interactions there. But like that's making me think, do we want 100% liquid contribution? And now we can still data map that, but now we're not changing any data. We're going from 100. I guess this would still remap it, but essentially this would be going from 100 to 100. But instead, do we just say that we are now applying gravity to it? Based on the age, we can. Oh, this is just a straight up condition now. Um, Jay, I don't think collision. Maybe you have a different definition of collision radius than what I'm thinking, but like the viscosity doesn't even have a radius. The radius is whatever the liquid is saying it is. So they should be 1-to-1. Like it doesn't even give you that an option for that to be wrong. But anyway, data mapper. What I want is a. Is it just a condition? Yeah, condition of the age. An age percentage. Oh, that's not exactly what I want. We need it's another data mapper, right? Does that apply a percentage? What I'm thinking is we make a gravity, and the gravity is limited by. I'm blanking on. I haven't done this particle stuff in a little bit. Um, does the gravity's not getting data mapped? How do we? Mm, I feel like I'm just derping on this particular aspect. Okay, in your second group, add a liquefy modifier last and choose set properties. And you'll get the collisions back. All right, well, let's just try that. So we liquefy. We're in this group. We'll add it last. Now this doesn't, wait, that doesn't make any sense to me. In your second group, add a liquid modifier last and choose set properties. But this means that they'll instantly be liquid, right? Because as soon as they're in this group, they will liquefy 100%. It'll just melt down. But then you've got a data mapper, which is changing that. Okay, maybe that makes sense. I might need to make it first. Yeah, see, it immediately falls. But if I put this first, then the data mapper is only modifying the liquid contribution. Nope, it still falls. Full collision, although it looks a little bit odd. A little trickier than I thought. Set properties, blah, 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 blah. Yeah. If it's last, it would make sense that it's just overriding everything. Who cares what the data mapper is doing if the liquefy is saying, like, no, set it to 100%. So that can't be the option. If it comes before the data mapper, then you'd think all the stuff is what's getting applied. But even that doesn't matter. Well, yeah, but yeah, that I don't see this liquefy making a difference here. I just don't see that making a difference. Nope, still gets overridden. I appreciate the attempt, Andy. I know it's hard to backseat drive on these things. There's more exploration we could do there. And yeah, I would need to tinker with it a little bit more because I imagine the actual rig would be pretty straightforward. It'd probably make for a pretty simple tutorial. I mean, I imagine that Maxon will have a tutorial out on that in like a week or something because it's such a really cool, obvious use case. And the example they had shown a couple months ago like looked amazing. But the order of these doesn't seem to be this liquefied either is doing nothing or it's doing everything because it's just in this group. Yep. So it seems like Andy has a very similar thing going on somewhere, but his is working. So I might just have some checkbox on or off or something that's making the order of operations be different. Yeah, that's all the data mapper's doing. It's just controlling the liquid contribution, which is from 0 to 100 based on the age. Yep. Well, that's all good. Let's see. I do want to see if yeah, I will continue to explore this more for sure. Um, but getting it to do super specific things in a first time attempt, is always going to be a little bit tricky here. Somebody had suggested like kind of goopy drips. Um, I've kind of lost the message. And then Jay was asking about comparing this system, this particle system to X particles. I just haven't used the X particles liquids in quite a few years. Um, I know they did some like really cool specific splash stuff and whatnot. So I just am not in a position to compare them overly directly. Um, um, where was that request? I guess there's quite a bit of chat here. Paul's saying it'd be nice to see some of these rendered as water or liquid. Of course, we need to let the render time process through that entire thing, which is going to be quite a bit of time. Let's begin. I want to start very much from pretty pretty much from scratch here. So we're going to delete a bunch of stuff out. So we'll keep the landscape. I think it's a good thing for it to collide with. It just gives us extra information about the properties that are going on. Hang on, incoming. I've been having like a single sneeze per live stream. I don't know what's up. But somebody said something about maybe stuff like melting through a grate, which sounds kind of interesting. I'm not sure how well it will work. So let's make this our grate. And we keep it kind of parametric by doing a couple of capsules. So I'm going to say select, and we can grab the select. And now with a kind of procedurally, I'm saying select all the polygons. And then I can say inset all the polygons. And then I can say, we could do, I guess I'll just say delete. And then we can delete the active selection, which is the middle one. So now I've got a little parametric kind of grid maker there. And we can add thicken, but it did seem like the new collider here adds thickness to it automatically, which is kind of cool. So maybe we'll just try that. So that should have some thickness to it. And now I did this parametrically because now we can just change the size of the holes here depending on what we're throwing at it. I am thinking we want to make that a little bit smaller, maybe a fewer polygons, just so I can do a smaller ball of goop here. So I do like the liquid fill emitter, so we'll start with that. And I do like that sphere. Boop. And render, display, use, wireframe, liquid fill based on a sphere packing. It's not too big. And we did set a global resolution, this default resolution. I'm going to drop it back down to 3. Maybe too much, maybe too little. Particle group, increase the radius up to 3. Liquid emitter, emits some nice bright, some super bright colors so we can see it easily. All right, that should all just work. Okay, default viscosity. This is now a collider, so it's colliding. So it definitely collides, but we're also getting them oozing through the hole. So, okay, so far so good. Blurp, blurp, blurp. Very, very splashy here. Yeah, I guess we're just kind of looking at what the behavior is. I will make a liquid mesh, which automatically meshes it. So, don't even have to link it. They definitely made the system super easy for like a new user to just pop open, be like, yeah, liquid emitter, liquid mesh, boom, you got it. I happen to pick a very waxy looking color. Okay, so now everything's moving through. I think we need to scale everything down. So we'll go to our scene scale, drop it down to 1. Our liquid emitter, we're going to make it significantly more viscous with more surface tension. We're going to give it some stickiness. I'm going to say 11, and then we're going to make our colliding plane. We learned, okay, it does still have some stickiness. Actually, it does because I copied that from our landscape. Blurb. Okay, so that's calming down. Oh, wow. Okay, that looked great. That looked amazing right out of the gate. Look how good that looks. Oh, goodness. Look at that. It's gooping down from all the holes where we had them. It's dripping from all of the holes. Some of this is escaping through the landscape. That's a little bit of a surprise. was doing such a good job of colliding earlier. Um, we can try increasing this thickness maybe. Let's take a look at that again. Blurb. Wow, look at that. Like I said, this tool is going to be amazing for MoGraph style simulations because, and even now, I mean, it's running relatively well. So if we keep on increasing, let's grab our radius and drop it to half. Keep in mind when you cut a voxel in half, you're actually, it's not double, it's double, double, double. So that's a massive increase in resolution and calculation time. Yeah, immediately you see the sphere having a lot more detail. So everything here is going to be like, we've changed the property of virtually every aspect of this. Oh, that looks so good though. Beautiful jellyfish, big old splat. Look at those tendrils fly out, like even based on viscosity, like taking off that orientation. Like that doesn't feel wrong. Um, look at these, like look at this very natural looking drip that we have coming down from there. Um, now just actually, yeah, why is so much of this escaping through? Had been doing earlier, is doing like a really good job. Now we shrank all the particles down smaller right here with the default radius, but I would think that with this being in the global setting, that would kind of be taken into account for everything else. We could increase our settings here, but I don't feel like those are the settings that would help with this collision. Now we can try changing this to pre-process close holes instead of thicken, which essentially means this giant open hole at the bottom of the landscape is going to get closed, and it's going to see it as a big solid thing. But I just have a feeling that it's not going to stop it. Blurp, blurp, blurp. Jellyfish. Let's see. It's doing an okay job. I mean, all that's going to be identical up there. But yeah, now, okay, now it's doing a better job colliding. I'm not sure why it didn't like the thicken, but the close hole seems to have helped, seemingly. So again, well, we've increased the resolution, but like this doesn't feel like a water simulation. Um, but yeah, look at that. Look at the detail on this thing. Very, very pleased with that. Now we could do, somebody sort of requesting like the way this might look as a render of some sort. We could try throwing a waxy material on here. I don't know how far we should push this, but let's go to all. What's going on here? Oh, we're in this subfolder down there. Let's see. Let's just search for our wax materials and see. Oh, that's a nice looking wax right there. Now, here's something that's slightly tricky. Our scene scale here is like way off. This wax is going to be designed, assuming it has subsurface, which would be crazy if wax didn't. Yeah, so it's got a bunch of subsurface on there. Subsurface is going to be designed to look correct at real world scale. Real world scale would mean that this person, well, it's like, here's the thing. So this is a very, very large splatter of wax right now. So if we wanted it to look really like kind of realistic for wax, we'd want to shrink the entire scale down until these drips and whatnot felt like they were the appropriate size for like a candle. So with that caveat in mind, let's grab an HDR. Collapse that down. HDR. I might just grab the standard interior. Give that a second to load. If you just drag any HDR into your viewport, it'll automatically make your dome light for you, which is lovely. And let's spin this around. So there's our light. I'm going to kind of go off to the side a little bit, so it's out of the frame, but it should be giving us a lot of kind of this rim light going on. I don't know how much that HDR is going to be able to contribute to subsurface, so we might just make a area light. But let's pop open Redshift and see what that gives us. Blurp. Okay, so the particles, it looks really weird because the particles are still rendering. So let's just say that, hey, particles don't render. Or actually, it's probably the particle group. So, hey, you don't render. Or do we... Let's refresh that. That's all I have to do, right? Because, yeah, Redshift sees particles by default. I might need to put a tag on there to tell it not to. Oh. But I guess... maybe that liquid mesh... Okay. That... Okay, well, right now we have a problem where we're seeing the particles and the mesh. So do we have to put a Redshift render tag on that? And then see particles, and now the mode is disabled. So now if I told that to not render, wait, what's going on here? Oh, Casey's saying that we need to make this. Oh yeah, we said that earlier in Redshift. We might need to generate this mesh. Okay, and immediately now it's a volume. We're suddenly getting that waxy vibe. So yeah, okay, that looks pretty good. Thanks, Casey. Smoothing. Let's crank up the smoothing a little bit, and maybe give it a couple extra iterations. I wonder if the normal. Well, we're not exporting the normal, but if I did export the normal, and then I'm curious if we add additional smoothing onto the normal, how much does that? No, it doesn't smooth that out. If I turn that off and on, I don't really see a difference, assuming that it's refreshing. But yeah, instant waxy look. I mean, we virtually didn't change any parameters here, which is pretty crazy. All we did was increase the viscosity and some surface tension. Pretty impressive, and it's a little bit sticky. Now, let's see. How far do I want to push this? Let's double our viscosity and our surface tension, and let's just give us an extra iteration on each of them for our render simulation settings. And if we wanted them to be more drippy, I feel like is drippiness mostly is drippiness this abstract concept of like drippiness, would that be most contributed to by surface tension? Because viscosity, I think, is how much they all want to come together. But then surface tension is more like, well, what's the outer shell want to do? And if the outer shell doesn't want to break, so I'm going to lower my viscosity and increase my surface tension. And what I'm hoping to get is something a little bit more drippy. Like, let's get some boogers hanging down here. We're outputting the mesh every frame, but that's fine. Now, on this initial hit, I would expect it to be pretty intense because we're throwing like a lot of like weight at this essentially. Oh, look at those! Look at these flaps there. Oh, look at these strings going. I think maybe we did. I'm hoping. I don't know for sure, but maybe this is kind of the formula. Like lower viscosity, higher surface tension, and look at these tendrils. Look at that one. That's amazing. All right, with me just guessing, I'm quite pleased with the result there. Like these are definitely very drippy. Wow. That is really fun. This is good. This is just a fun tool to play around with. Oh, I didn't realize that we're already after 4. Well, anyway, not surprising. We have a brand new simulation tool to play with that we have never had in cinema. Well, definitely not vanilla cinema. Look at that. That's crazy. Let's see how that looks. Blurp. It's kind of fleshy looking. Let's go slightly less fleshy. Pink. And surface. Yeah, that's also. Let's go a little more pink there. Actually, yeah, this makes sense because we're doing 100% weighting on our subsurface, so all the color is coming from this. Scale. Let's see. Do we want that to be higher or lower? I think higher. Yeah, as I go higher, you can see, like by making this higher, we're kind of faking it to make it look like it's thinner. So we're getting more light contribution by increasing the scale. Yeah, so if we go really far, it's going to start looking like really, really transparent. Almost glass-like. Look at that. Our I can't believe how well that wire. I didn't even modify the geometry. Our little wire grate up here just perfectly worked for what I was aiming for. Um, let's increase. So maybe the splat doesn't quite escape. And we'll go 6 by 6, and just we're just playing. I'm glad we kept this landscape here. Like it just makes everything so much more interesting when something's colliding with that. A couple of strays escaped there. Blurp. Let's see. How did our top splat go? Yeah, look at that. That looks amazing. Very liquidy bubblegum. Nice tendrils. Okay, let's at this point we just have a nice rig here, and I'll give it a save just in case. Um let's see. Waxy splat. Now I just want to kind of play with some of those ingredients here. If we increase our surface tension even more and lower our viscosity back to the original 0.1, what does that do? Like I in my head, I feel like this is a little too far, but let's just see what it does. Okay, that's explodey. Okay, I mean it looks cool, but okay, not a good formula. Um, there's so much surface tension that's probably adding in like a lot of energy to this. So let's try zero 0.5 on the viscosity. If that doesn't work, we can try increasing our subframes. Okay, that holds together at least. But yeah, 0.1. We still got, yeah, that's still lower and the surface tension is still higher. Blurb. Oh, that's interesting. Oh, that's that surface tension, I guess. It popped like a bubble. That was cool. I'm gonna try. There's a lot of energy here, so where is our damping simulations? Okay, it's taking. I gotta override it, and let's add way more damping. It's gonna slow everything down. There's a lot of energy coming out from this right now. I kind of want gravity. I want there to not be a lot of kind of like velocity in the individual particles. That's So anyway, I just want those the way those tendrils are shooting out sideways. It does make sense to me because if it's like the stuff is being forced through kind of sideways because all the volume is above it. So if we put some damping on there, yeah, as soon as we put some damping, then a lot of energy is being drained out, and then we're constantly adding energy back into the system again from gravity. So now they don't shoot out as far, and now they just want to droop down more. Now we were having all kinds of trouble, but I wonder if we can do a quick data mapper here. Data mapper that's applying to everything. I'm going to map the age, yeah, the absolute age. We're going to start at age 30 and then go up to age, I don't know, 200 ish. And then we are going to control out a custom property. And the custom property will be the viscosity. And in the beginning, we're going to have a really high viscosity. And then eventually, we're going to lower it down to that 0.5. So the idea here is that it really wants to be a sphere, not a perfect sphere, but it wants to be a sphere. And then after frame 30, it's going to slowly, cohere with itself less. So my hope here is that we get a blob, maybe a little bit of drip, and then as time goes on, it becomes more and more drippy. This volume calculation on a mesh is amazing. That works so well. Okay, yeah. Already you can. I feel like I see these holding together a little bit better. Um, so this is still full power. Even just increasing that viscosity just stopped those from like shooting out. Um, and yeah, only right now it's that was all default. So now it's starting to get a lower and lower viscosity. Look how, I mean, considering this is pure simulation, look how identical those all are. It's like just a giant random pile of particles colliding with geometry that's got very even holes, and then we get a very even result from each of them. Anyway, oh man, do you remember the old goo rock tutorial? Look at this. We're doing it for real now. Oh, wait, are those passing through? Oh, yeah, it makes sense that those would be passing through slightly because this doesn't have any actual thickness. Um, but yeah, some of the shapes are kind of interesting. Like the way it almost looks like it's curling underneath. But a little actual geometry thickness would look great. Would look great. Yeah, and then over some time, those will break. Surface tension. I mean, it's like with the correct application of surface tension, I wouldn't be surprised if we get like how even like there's a thicker drop here, and as it stretches, those are actually getting thinner. Like this is essentially, this is real. This is like the way it works in real life. And yeah, actually, look, that's exactly what I was hoping for. Look, this as soon as it let go of its weight, it actually recessed back up, because there wasn't as much weight pulling down on it, and then I don't know, depending on our viscosity as it keeps on going, it's going to start stretching itself back down again because more particles are going over to it. Yeah, I put my mouse there, and now you can see another drip is starting to form. This is just exactly the behaving the way you would want it to, like essentially kind of realistically. The ones in the middle have had this constant stream because that's where a lot of the mass was, or these outer ones are less so. Splat, splat. Oh, it looks so good. All right, I'm very pleased. I'm saying at some point we'll get that elephant, or we'll get the melting effect going. But this was really fun to move over to and tinker with. Um, Subsurface a little strong. Let's go to 2. Yeah, there's a little subsurface. Damn, that looks great. And yeah, I don't know. Any specific follow ups to this one? There's so many more things that we can explore as far as like potentially in the future, not now, but so many more things to explore as far as like mixing different materials on there, making like one color go to a different color, and then all sorts of melting effects, reforming effects. The like you can make something be liquidy and then not be liquidy. Even here, it's like in theory, I don't know, but I would imagine that we can. There's various settings that we could do here that would make these essentially freeze in place. Even now, we could just say velocity equals 0, and they'll just kind of freeze, and we could slow everything down. But essentially, we could make things be very liquidy, solid, liquidy, melt, drippy, like this, and then re-solidify back down again. And all those could be turning different colors as those different actions are happening. Nice smooth transitions between them. Look how nice that shape is. That's great looking. And even here, like just as a model, like maybe it is asking for trouble, but this is returning real geometry. So if we were to throw this into a remesher, and I'm going to say, hey, return this at 10% the polygon count. We're throwing a lot at it, but if I just wanted like a static model, yeah, so that's now remeshed it. And now we've got this very low poly kind of smooth version of it. And it doesn't even have any smoothing tag on there. So just put a let's put a weighted area map on there, and then that looks super smooth. And now we have like really clean geometry. This would not be for an animation because then this would remesh and kind of blip all over the place every single frame. But like, look how nice of a mesh that we now have. If we wanted this to be like a static model and make this editable, let's say you were making an ice cream cone and you want to drip ice cream on it as a modeling technique. So you could make this liquid, remesh it, make it editable, and there you go. Now you've got your liquid topping on there with some pretty nice topography. Like all dripping through. So yeah, huge. This is a huge addition. We've been hoping for some liquid simulations for a while in cinema. So pairing this on top of the particle system, I really like the integration. There's so many different, like there's so much power in the system. We still haven't done too much with the custom data. We talked a little bit about it, but at some point, we got to do like a big old project using custom data. I think we do some crazy things. Um, Debo Animation, thanks for subscribing with Prime. Appreciate that. Yep, love the data mapper. Data mapper is so powerful. It's really fun. Um, let's see. Um, yeah. We did have to add a collide modifier to the geometry, but the liquid itself comes with its own collision. Um, then let's see. Zach is asking about. Okay, somebody already answered, but Zach was asking if motion blur worked and the liquid mesh can export the velocity data. So I imagine that can be piped through into maybe Redshift, so that can use that velocity information for motion blur purposes. I haven't actually done it, but makes sense. Um, and apparently that's the way it works when you get simulations from LiquidGen or Houdini. So yeah, that's cool. Oh yeah, Casey saying back in my day, subsurface scattering would take 2 days to render, and here it's just like, oh, tweak, tweak, tweak. It's like so good, um, nice and speedy. But anyway, I do believe that we should wrap this up. I wouldn't be surprised if we end up tackling maybe some. Well, next week is supposed to be Jonathan Winbush is going to be a guest on the stream, and I really want to do that. And we're going to be talking a bunch about C4D to Unreal. So that's still in the cards. That's what we're aiming for. But we had a nice long episode for today, and I was attending a 2-hour meeting before that, so I've now been standing for almost 5 hours straight, um, in one spot. The I think soon I'm about to launch a couple new betas into my to my beta group, but I think I'm going to do a live demo of one of our upcoming plugins soon because I'm excited for what those are. And yeah, there's other cool stuff in the works that I can't really talk about yet, but yep, things are moving and shaking, getting excited. So anyway, I think that we are going to wrap this one up. Thank you so much, everybody, for coming and hanging out. As always, you can go head on over to rocketlasso.com and head to the community tab, and you can join the official Slack channel if you want to. In addition to that, probably somewhere below in the description, you can subscribe to the Rocket Lasso newsletter. You can, well, of course, and the best way of supporting it, you can get this. That's what I was going to say. The scene files, all the scene files I just made, especially this waxy splat one. I'll save another iteration of this current version of it. You get access to all those scene files if you want, and all the other ones, of course. You get discounts to all the plugins. And of course, the best way to support Rocket Lasso is if you buy one of our plugins. Buy our plugin, you get some new superpowers inside of C4D, and it helps us continue making this type of stuff. But anyway, I think that's going to wrap this one up. Thank you so much, everybody, for coming and hanging out as always. But until next week, bye bye.